My name is Jim Morré. I have a PhD in biochemistry from the California Institute of Technology. I'm currently Chief Executive Officer and Director of Research at Morré, located in the Purdue Research Park in West Lafayette, Indiana. Morré is the commercial developer of the ONCOblot test. It was founded by myself and Dr. Dorothy Morré, who has participated equally in the research leading up to the development of the ONCOblot test. And Morré is basically, its mission is to bring the ONCOblot test into the clinic. I first started showing interest in research at, I guess, an extremely early age. My first vivid recollection of being involved in research when I was about 6 years old. Curious about nature and this sort of thing all through grade school and high school. And I booted off to the University of Missouri, where I was going to school, and worked in the agronomy department. And my first job was to spray weeds with the herbicide 2,4-D. Now, 2,4-D is a really interesting compound. It kills weeds by causing them to undergo unregulated growth. They just grow completely out of control until they finally die. Each day as I went to the farm to work, I'd stop and look at them and observe them. And I became interested very much in what this herbicide was doing. So I went to the library and read everything I could, and I read one article by a scientist from the University of Michigan that commented also on the unregulated growth part of it. And his thought was that if you could understand how 2,4-D killed plants, you could understand cancer.
I'm Dr. David Taggart. I have a PhD in biochemistry from the University of Wisconsin in Madison. The ONCOblot test is a blood serum test for the detection of the ENOX2 cancer marker. The ENOX2 cancer marker is produced by malignant cells, and it's shed into blood serum. We are able to take those blood serum proteins and we will separate them by using two-dimensional gel electrophoresis. In the first dimension, we separate proteins according to isoelectric point, and in the second dimension, we will separate proteins according to molecular weight. And then finally, we will detect all the ENOX2 proteins by using an ENOX2 specific antibody to detect all of the ENOX2 proteins on a membrane. And then according to where those proteins are in the membrane, we can then calculate their exact molecular weight and isoelectric point. We will compare all of the characteristics of any ENOX2 proteins detected versus a database that we've developed by analyzing the serum of people with clinically confirmed cancer. And in this way, not only can we detect ENOX2, which is indicative of cancer presence, but also assign a tissue of origin to any cancer that is detected.
The ultimate goal is to utilize this technology to prevent cancer or to reduce cancer from an acute illness, life-threatening and almost universally fatal, to a chronic disease that can be detected early and treated early and cured.
I don't know if cancer will ever be completely eliminated, but with major technological advancements such as the ONCOblot test, I think that we've taken a major step towards that goal.